Welcome back. Problem 11-23. Statement is the beam is constructed from 3 boards as shown. If each nail support a shear force of 50 pound, determine the maximum spaces of nail S, S dash and S double dash for region A, B, B, C and C, D. So you can see this is the beam, clear, and the load acting is 800 pound and at C it is 1200 pound. So you have to determine the space between the nails. At region AB is S, in region BC is S double dash and in region CD is S double dash. Clear? So let's start with the solution. The cross section of the beam is given as this consists of 3 boards that are nailed together. So we know that solution will start from, we know that shear force is equal to V into Q divided by I, or you know that shear flow, which is the horizontal shear force per unit length, is VQ divided by I. So we will need the shear force, we will need the moment of inertia of this beam and Q as well. So what we will do, we will find the shear force for region A, B, B, C and C, D. So for that we will remove this support at point B. So if you remove the support at point B, so there will be a reaction force which is RB. Similarly, if you remove this pin support at point D, so you will be having a reaction force which will be represented as RD. Now we'll find this RB and RD by using equilibrium condition. So first equilibrium condition is sum of all moment about point D is equal to 0 and taking the counterclockwise movement as positive. So first movement due at about point D is due to this 800 pound loads and perpendicular distance is 15 and that is producing clockwise, so it will be positive. The second movement will be RB into perpendicular distance is 10 and this is producing clockwise, it will be negative. The third movement will be 1200 into perpendicular distance is 5 and that will also produce counterclockwise, so it will be positive. But the sum of all movement will be 0 about this point D. So I will write 800 into 15 minus RB into 10 plus 1200 into 5, that is equal to 0. So we will get 10 RB will be equal to 18,000. Clear? So from here you will get RB will be equal to 1800 pounds. Now you have RB, you can find RD by using this condition that sum of all forces along y direction must be equal to 0 and upward force is positive. So one force is this one, which is minus 800 plus RB minus 1200 plus RD will be equal to 0. So I will write minus 800 plus RB is 1800, clear, minus 1200 plus RD is equal to 0. So from here when you calculate, you will get RD will be equal to 200 pounds. Now you have both this RB and RD, so we will move toward drawing shear force and bending moment diagram. So for that you have to take vertical lines from the end of this beam, clear, and there is a horizontal line which will determine the length of this beam, and this length will be X will be in feet. Okay, so here we will be having shear force and unit will be in pounds. So let each division is taken as 500, so it will be 1000 pound. Similarly minus 500 minus 1000 pound. Now at point A you can see you have A minus 800, so minus 800 will be somewhere here, so it will be minus 800. Now moving from this is point A, this will be your point B, clear, this will be your point C and this is your point D. So moving you can see that moving from A to B, there is no other force, that is minus 800. So it will remain same till at point B. Okay, now minus 800, and at here you can see you have RB, which is 1800. So minus 800 plus 1800 will bring it to 1000. So shear force will change to 1000. Okay. Now from B to C, you can see there is no other force, so it will remain same horizontal. But at point C, you can see you have minus 1200. So 1000 minus 1200 will bring it to minus 200. So let this is your minus 200. So it will change to minus 200. This is 1000. This is minus 200. And it will remain same till at the end. And at the end, you can see you have RD, which is plus 200. So minus 100, 200 plus 200 will bring it to 0. So this is your shear force diagram. Now this is shear force diagram. So from shear force diagram SFD, you will get maximum value of shear force absolute value is 1000 pound. You can see this is 1000 pound. Okay. And for as we are talking about the regions, so I will also define the shear force for region AB. This is point A. So for region AB, you have shear force is equal to 800, absolute value will be 800 pounds. For region BC, you will have absolute value of shear force is 1000 pounds. And for region CD, you have maximum value of absolute value of shear force is 200 pounds. Because we are dealing with the regions, so I will need this value for region AB, this value for region BC, and this value for region CD. Now what we will do is that we will find I for this beam. So the cross section is given over here. So first of all, we will know the centroidal axis, the axis which is passing through centroid. By using this formula, y bar is equal to sum of y dash bar into A divided by sum of area. Since this are 3, so let this is your 1 and these are your 2. These two are same. So what we will do is that first I will write the formula. If we expand it, so y1 bar dash into A1 plus 2 times y2 dash into A2 divided by A1 plus 2 times A2, which will give you y dash. So I will write y dash is equal to y1 into area A1. So if you take this upper line as a reference, so this is the first area, which is, this will be A1, this will be A1, and this will be A2. These two will be A2. So A1 is, you can see 8 by 1. So A1 is 8 by 1. And what will be y1 dash? So y1 dash will be distance from top till the mid of first section. So this will be your y1 dash bar. And that is 1 by 2. So which is 0.5 inch. So multiply by 0.5 plus 2. Now what is y2? So y2 is this one. So this area, A2 is 6 by 1 inch. So this is area A2, 6 by 1 into y2. What is y2? So mid of this from the top. So mid of A2 is 3. Basically this distance is 3 inch plus 1, 4. So this is y2 dash bar, which is equal to 4 inch. So I will multiply it with 4. divide by A1. So A1 is 8 multiplied by 1 plus 2 times A2 is 6 multiplied by 1. So when you solve this, you will get y dash bar will be equal to 2.6 inch from the top. So its neutral axis will lie 2.6 inch from the top. So let 2.6 is this one. Let consider this is 2.6 from the top. So this is your y bar, 2.6 inch. Okay. Now we have this y bar, so we can find the moment of inertia I by using parallel axis theorem, because this neutral axis is not in the mid. So we will write sum of I dash plus AD square. So for member 1, since this is 1, so it will be equal to 1 over 12, breadth which is 8 and height is 1 cube, plus area which is 8 into 1. And what is d square? So d square is distance from neutral axis till the mid of this section. So this is your d1 for this member 1. So d1. And you can see this d1 is equal to y dash minus y1 dash bar. So y dash is 2.6 minus y dash is 0.5. Clear? So this is your d1. So this is d square, so d1 will be equal to 2.6 minus 0.5 whole square, plus 2 times, now second member is this, so its width is 1 into height is 6 cube, plus 1 into 6. And what will be d2 square? So d2 square is distance from neutral axis till mid of this. So this is d2. This is d2. And you can see this is equal to y2 dash. d2 is equal to y2 dash bar minus y dash. Since y2 dash is 4 inch, so 4 minus y dash is 2.6 inch, so d square. Now when you solve this, you will get the moment of inertia I will be equal to 95.47 inch power 4. Okay, so we have V, we have I, we have V. For different region we will find Q. So what will be the value of Q? So Q will be equal to, as we are interested to find out the shear force in between the nail, so we will take this area. We know that Q is equal to y dash bar into A. So y dash area is 8 into 1. Clear? And what will be y bar? So y bar is distance from neutral axis till the mid of this. This distance is y bar, and this distance is equal to y dash, which is 2.6 minus 0.5. So when you solve this, you will get Q as well. So Q will be equal to 16.8 inch cubic inch. Now we will move for different region. Okay, so for region AB, we have shear force is equal to 800 pounds, that is shown over here, AB region 800 pounds. Clear? You have Q is equal to 16.8 cubic inch and I is equal to 95.47 inch power 4. So we know that shear flow Q is equal to V into Q divided by I. So put the value 800 into 16.8 divided by I is 95.47. So it will give you 140.8 pounds per inch. This is shear flow. So what we know, that shear flow is equal to horizontal shear force per unit length. Clear? So now here, if you look into the figure, so this nail is also with this. So we will take this total distance, which is 2s. Clear? In order to find the shear flow over the length of 2s, and then we will convert it into s. So horizontal shear force per unit, which is 2, we are taking 2s. So from here you will get FH is equal to Q divided by 2s. 2s is why? Because one nail is contributing on both sides. So we will divide it by 2. So you have the value 140, FH is equal to horizontal shear force per unit length. Clear? So we are interested to find out this 2s or s. Clear? So from here 2s will be equal to FH divided by Q, and if you further simplify it, Fs will be equal to FH over 2Q. So put the value FH is given in the question is 50 pounds. Let me show it as well. That is 50 pounds. Clear? Divide by 2 times Q is 140.8. So when you solve this, you will get S will be equal to 0.710 inch. This is the distance between nail for region AB. Now we will move for region BC. For region BC, we have shear force of 1000 pound. Q will be same 16.8 cubic inch. I is 95.47 inch power 4, and horizontal shear force is 50 pound. So you can just put it the formula. Now the distance in region between BC is S dash. So S dash is equal to FH over 2Q, and Q is equal to VQ divided by I. So V is 1000, Q is 16.8, and I is 95.47. So you will get a shear flow which is equal to 176 pound per inch. Now you can put the value over here. So 50 divided by 2 into 176 will give you 0.568 inch as well. So this is the horizontal nail spacing for region BC. And last thing, for region CD, we have Q is equal to V in region CD is 200. So 200 into Q is 116.8 divided by I is 95.47. So you will get 35.2 pounds per inch. And the nail spacing between in region CD is S double dash, which is equal to FH over 2Q. So F is 50 and 2 multiplied by 35.2. Okay, I think I have made a mistake. This is... So mistake is that this is not 2S, okay? Because you can see that this is the nail. Clear? So horizontal shear force will be divided by 2 because half will be in this portion and half will be in this portion. So instead of 2S, let me correct it. This is S and this will be Q by 2. So S will be equal to Q divided by 2. This is not 2Q. This is Q divided by 2. So you will get this value. Okay. Same is the case here, as dash will be equal to Q divided by 2. So 176 divided by 2 will give you this answer. And same here, this will be equal to Q divided by 2. So when you solve this, you will get S double dash is 2.84 inch. And this is the nail spacing for region CD. And that was all about this problem 11-23. I hope you have enjoyed this video and you have learned it. Sometime it happens, and we also got confused during the explanation, but at the end the concept is clear, and I hope you have learned from it. Thank you for watching.